Hey, this is Donald Heslop from Padlock Technologies, dual CCIE, and owner and principal, here to talk about SXP reflection. So this is a special technique for people who do not want to do inline tagging, or their equipment can't do inline tagging, and they have a lot of switches and they do not want to have individual SXP connections to ICE because ICE has its own limitations and take it can't take a lot of SXP connections. So SXP is basically a control plane protocol that distributes the IP to SGT mappings from ICE to a certain node. So in normal design, you would have ICE over here, and ICE is going to have the XXP function. And then let's say you have a bunch of switches here. Bunch of switches. Now this is not a cloth fabric or anything like that. This is just a bunch of switches in the environment. Right? And we'll just do intermediate switches here as a cloud. So in an XXP design, if you wanted to do, depending on your enforcement point, you would have, let's say your access switches, access switches, access switches, access switches. Let's say these may be either distros or core switches. You would each have an SXP connection to ICE, right? If you wanted to do this. Now, you don't necessarily have to do this, but it really depends on your design, right? So you have all these SXP connections, and then the IP to SGT mappings would go to each one of these switches. Now, if you had thousands of switches, you are going to hit a limitation in ICE because you should not be sending thousands of SXP connections, and you're not doing inline tagging, which is a different propagation method. So with SXP reflection, what you would do is you are going to send, or you're going to create a connection between one or two switches. So let's say we're going to have an XXP connection for this switch, and then we're going to have an XXP connection to this switch. ICE is going to be the speaker, because there's two modes here. There's speakers, and then these two switches are going to be listeners. And then these switches at the bottom are going to be listeners to these switches, to the distro switches. And then the distro switches are going to be speakers, speakers, speaker, and then the rest of these down here are going to be listeners. And that's if you wanted to do enforcement at the access layer without like doing it close to the source. Because TrustSec is basically an egress technique, and it's different from what you were taught, because when what you were taught is you want to put the ACL closest to the source as possible. With TrustSec, you actually are going to go closest to the destination as possible. That's why I say it's an egress technique. In this situation, you are going to enforce on the access switch for, let's say if it was a computer here, and this is called inter switch. So computer here and a computer here. Now normally you can do the enforcement here on the distro switch if you wanted to do that. But let's say you didn't want to do that. You didn't actually want to do TrustSec enforcement on the distro switches. You just want them to send the IP to SGT mappings that come from ICE to the access switches, and you're going to do the enforcement here. Well, in order to do enforcement, you need 5 things. You need a source tag, you need a destination tag, you need an enforcement point, you need a policy, and you need an interface. So you need those 5 things for TrustSec to technically work. In order for me to enforce a policy between, say this was SGT tag 100, and say this was SGT tag or SGT 200, you would have a policy here that says 100 is denied to 200. Well, you need the SXP to send this tag over to 100 and vice versa. If you don't have the tag, the policy will not work. If you don't have both tags, the source and destination, and the policy, and the enforcement point, and the interface, TrustSec will not work. So this whole SXP reflection technique is to use these distro switches to send these tags amongst all the switches at the access layer. So now, let's say this IP address was 192.168.1.2, and this one was 192.168.2.2. This switch now will know that it will know its local tag, which is this 192.168.1.2 is SGT tag 100, and now through SXP it will know that 192.168.2.2 is SGT 200 because of XXP, because the distro switches sent it down to the access switches. This is done through a radius session. The radius session goes to ICE. ICE gets the tag, sends that tag to the distro switch. Distro switch sends it down to the access list, and then vice versa on the other side, which would be 192.168.1.2 is SGT 100. So now when you have your policy that says 100 deny 200, so deny IP to 200, no matter where you plug this in, as long as they get authorized and they get the same SGT tag of 100 and 200 amongst these access switches, you can deny access, right? You can deny access at the inter-switch level, which is different port, different switch, or intra-switch level, which is same switch, different port. This technique is, sparingly, most people don't do this if you can afford it, right? If you have devices that can do inline tagging, it's better to use inline tagging because that tag gets put into the Cisco metadata that's in the frame in the frame. So that will actually get propagated amongst all the switches, and you don't have to worry about, the limitations of XXP. And because since this is a control plane protocol, if anything in the middle is blocking, I think it's 64999, you can have control plane problems when it comes to XXP. So once again, this is a one-off situation technique that most people don't use because they're not doing XXP in this advanced feature. But if you are somebody that is looking to probably do this or looking for a different design, I'm going to put a link in the description to start a discovery call with me, and we can look at your environment and see how we can help you put ICE in your environment or fix some of the things that may be going wrong with your ICE deployment. Once again, this is Donald from Padlock Technology, dual CCIE and owner and principal. Hopefully this was informative. Thank you and have a nice day.